Every investigation has experimental error because of its limitations. When you take your readings, you're never going to be perfectly accurate and precise. You try to be as accurate and precise as you can by reducing your experimental error, reducing the limitations as much as possible. But you will always have a little bit of experimental error, no matter how hard you try. And that experimental error is not significant. It needs to be ignored. Otherwise, you won't see the pattern that is actually in nature, which your data is trying to show you. So there are various ways to reduce experimental error. One is we must have numerous samples per treatment. We must repeat the same thing over and over and take many measurements and then get an average. And that improves the likelihood that we're going to be accurate, because it's very likely if we only take one reading that reading might be very wrong. Whereas if we take very, very many readings, it's not so likely that every single one of them, or the majority even of them, are going to be very wrong. Another way that we ignore insignificant variation is that when we plot our data in a graph, we draw a trend line, and the trend line gives a smooth relationship between data points. And so that predicts the pattern that nature has, because nature tends to have smooth relationships between variables. And so we mustn't go dot to dot to dot when we're plotting a graph, because that's drawing attention to experimental error rather than ignoring experimental error, ignoring insignificant variation.